Geometry Unit 13, Sections 2 and 3. We're doing a combined video for Sections 2 and 3. Section 2 is about inscribed angles, and Section 3 is about the angle measure of arcs. So this first question, the measure of arcs AB, BC, CE, and EA are in a ratio of 3, 4, 5 to 6. Find the measure of some things. Anytime you're given the measure of things in a ratio like this, you take that 3, 4, 5, 6, and you turn it into 3x plus 4x plus 5x plus 6x, and you set that sum equal to whatever these arcs add to. Now, AB, BC, CE, and AE, that combines to be the whole circle, so we know that's a total of 360 degrees. So if we add these four arcs together, we get 360. The reason why we have attached x to each of them is because we don't know what the ratio is. They're 3, 4, 5 to 6 in a ratio, but is it that it's 30, 40, 50, 60, or is it 60, 80, 100, 120? That would still give us 3, 4, 5, 6 ratio. So we have to find out what that multiplier x is. So basically, like I said, it's really not very complicated. Just attach x to each of them, add them up, and set it equal to 360 if it's the full circle, 180 if it's, half of it, or whatever the problem may require. So this is a total of how many x's here? So we got 7 and 11, looks like 18. X equals 360. And so a little division, and I think we're going to get x equals 20 here. Let me double check my math. 360 divided by 18. And indeed it is 20. Now that x equals 20 is great, but I then need to go back and figure out what each of these things are. What is 3x? What is 4x, 5x, 6x? So for 3 being 3x with x being 20, that's 3 times 20 is 60. 3 times 4 times 20 is 80. 5 times 20 is 100. And 6 times 20 is 120. And these measurements correspond to these, and the first one corresponds to AB, the second one BC, the third one CE, and the last one EA. So they're in the proper, the order they're listed here, that's the order they're mentioned here. So AB is the first one mentioned, that's my 60. And BC is next, that's going to be the 80, followed by the 100. CE and EA is 120. And of course, it should look like this one's smaller than this, and so on. Then from that, what's the measure of arc CE? Well, we just determined that arc CE is 100 degrees. And how about angle AOB? Well, angle AOB is a central angle because it's at the center, and central angles equal our arc measurements. So that would make that 60 degrees. And so that was the rule for central angles, is they equal the measurement of their arcs. Inscribed angles are a little bit different. But first, again, let's do some vocab. Chords we've talked about. Chords in this diagram, BD would be an example of a chord. AD, the diameter, that's also could be considered a chord, but BD is definitely a chord, and it's not a diameter. It's a line, a segment in the circle. A secant is something new. We haven't talked about a secant yet. A secant is a line segment that has an inside part of the circle, but also an outside part of the circle, like BDG is a secant. Like, again, let me use my highlighter tool to show you what I'm talking about here, that if I'm just looking at this piece here, that would be considered a chord. But if I'm going to extend it out to G, this is now called a secant, a line that goes through a circle and even extends out here. We could have a point out here and call it something too, but that's a secant, that there's an interior part and an exterior part to a secant. Chords only have an interior part, but secants have interior and exterior. So let me write that little note here. There is an interior and exterior parts. Chords are all interior. A tangent is all exterior. So how could you have a line on a circle that's not in it at all? Well, tangents don't go in the circles. Tangents kind of just brush up against the side and only hit it in one spot. That's what EF here is. It is a tangent to the circle. It does not go through the circle. It just hits the very edge of the circle in one location. If we were to raise this up a little bit so that it hits twice, then it become a secant. The fact that it's only hitting the edge of the circle once, it's not going inside the circle at all, because to go inside the circle means you're going to also come out somewhere else, and that means you're hitting twice. But here we're just hitting in one spot. That's what's called tangent. And this is actually where the, so this would be EF. This is where the phrasing tangent comes from in trigonometry, like, sine, cosine, and tangent. Well, it comes from the fact that tangent to what's called the unit circle in trigonometry. You'll learn more about that in Algebra 2, but they are related. It's not just a coincidence that it's the same word there. But a chord is all interior, a tangent's all exterior. A secant has an inside part and an outside part, interior and exterior. Now, an inscribed angle is an angle whose vertex is on the circles, not at the center of the circle, but on the circle. So if I were to, erase some of this here, we talked about central angles, and a central angle is at the center of the circle. This would, let me go back to green. A inscribed angle, like those ones that are open to a diameter, the vertex is at on the circle. Sorry, I'm tripping up my words. This right here, like this angle right here, angle BDA. Remember, the middle letter is your vertex whenever you're listing an angle, angle BDA. And we see that the vertex is on the circle. Now, it does happen to go through the center, but that doesn't have to. And so that's called an inscribed angle. We've heard the term inscribed before, like if you have a triangle inscribed in a circle, right? That means that all the points are on the circle, or we saw I think we did a hexagon inscribed in a circle, right? And that's again where it was all the vertices are on the circle. So that's what inscribed means, is vertex on the circle. And the rule for an inscribed angle is that the degree measure of an inscribed angle is half the measure of the intercepted arc. So for example, if this arc was 40, this angle in here would be 20. It's very simple. We could also go the other way. We could say the degree measure of the arc is double or 2 times the measure of the inscribed angle. Like we're saying 20 is half of 40, well 40 is double 20, so it goes both ways. But the inscribed angle is half the arc is really the best way. Whereas a central angle, like we saw yesterday, that equals the arc. So just a couple quick practice problems, and then we'll do a lot more of this in class. Measure of arc CD, this is supposed to be an arc symbol, is 70 degrees. What is the measure of ADC? Well, the first thing you want to do with these circle questions is identify what type of angle is it. And right now it's basically, is it inscribed or is it central? And the fact that we're on the circle itself means this is an inscribed angle, and it's half of its arc. Now, this is a pretty easy example. I think you could probably see this really well. That what's the arc that the angle is intercepting? And the arc here would be AC. If you can't see it well, highlighters are very useful. Like if you trace out the angle, and you say, all right, it goes from A to C. So that arc in there is the arc inside that angle. So this inscribed angle is going to be half of that arc. Now, I don't know what that arc is. So the first task is to figure out what is this arc measurement. And the key here is recognizing that AD is a diameter. And diameters cut our circle in half. So that means that this whole thing is 180. And if that whole thing's 180, this must be 110. Together they form half your circle, 180. And if that's 110, my inscribed angle is going to be half that measurement. That would be 55 degrees. Okay, so ADC equals 55 degrees. One more quick example. BOC is 60 degrees. So sometimes you're given an arc and ask for an angle. Sometimes you're given an angle and ask for an arc, or an angle and ask for a different angle. Okay, but we're given this angle BOC. What type of angle is it? BOC is a central angle because its vertex is at the center. So that means it equals the arc. Basically, every time you're given an angle, you want to try to find an arc measurement. And every time you're given an arc measurement, you want to try to find an angle measurement type of thing, or another arc measurement. You're always trying to find more from what you're given. That's basically what geometry is. And so I see the central angle equals the arc. So that means arc BC must be 60. And well, I'm asked to find angle BEC. So that's BEC. C. What type of angle is that? That is an inscribed angle. You guessed it. All right. And so we know it's going to be half the arc, and it happens to also have the same arc of BC, so that would then be half the arc 30. Basically, if a central angle and an inscribed angle have the same intercepted arc, then the inscribed angle is going to be half the central angle. And that's basically it. It's just kind of playing with these properties back and forth. But we're going to experiment and play with this a lot more in class. See ya.